Today we're going to continue the discussion on VPN bonding. In our previous labs, we talked about the three options for VPN bonding. VPN bonding is essentially to have redundant VPN connections across any WAN, either it's mobile connections or normal internet connections or MPLS. So we talked about one of the options was for multi-WAN. Using multi-WAN, essentially multi-WAN provides the link redundancy. Then we built a single tunnel across multi-WAN. So the failover is really achieved by multi-WAN failover capability. The other option was discussed in previous lab was to use Ospf. Ospf is basically we're making use of Ospf dynamic routing protocol to do the failover between multiple VPN tunnels. So we just built one VPN tunnel for each of the link. So when you have multiple link, maybe you could have LTE or maybe many more connections. So we just have one tunnel for each of the connection and using Ospf to do the route path selection or auto failover or load balancing. So the other option we're going to cover today is to use LACP, which is Link Aggregation Control Protocol. It's a standard IEEE protocol for bonding multiple layer 2 physical interfaces. We can use the same protocol to bond VPN tunnels, layer 2 VPN tunnels as well. So if you look at today's lab topology, it's really similar to Ospf. We're going to have one tunnel for each of the connections that we're going to use. So I'm going to have a HSA with dual LTE. So we're going to have a tunnel across each LTE connection. Then we will do a bonding for the two tunnels to have one aggregated logical bonding interface, as if it is one physical interface across the WAN. And we get an aggregated bandwidth as well. And the major difference between Ospf bonding and LACP bonding is for Ospf bonding, we really have separate multiple VPN tunnels and the failover is achieved. Or failover, whether it's failover or load balancing is achieved by using Ospf load balancing or dynamic routing capabilities. So the failover is really the speed of the failover is really depending on the Ospf hello timers. So for example, if this tunnel goes down and the Ospf will learn this path is gone, the traffic will forward through the other path. So the failover time is depending on the how fast the Ospf can converge the routes. But the other difference is because we're using Ospf, so the tunnel can be, the remote end can have separate CMG. That means the tunnel, the two tunnels don't have to terminate on the same CMG. We can have one tunnel on this CMG, the other tunnel terminate on the other CMG, and these two CMG can run Ospf. So we form an Ospf domain between multiple CMGs and HSA. So because we're just using dynamic routing protocol to do the route selection, to do the load balancing, so it's independent of how the hardware or rather the gateway side is connected. But if we're going to use LACP, the difference is because LACP is point-to-point. So that means the two tunnels have to terminate on the same CMG. And also, but because it's, we're using the LACP to do the failover, so the failover is between the two tunnels is very fast. It's very fast. It's just like how typical two Ethernet ports are bonded together. So we're going to do a demo on this later. So again, the key difference, the tunnels failover using Ospf are achieved by the dynamic routing protocol. So the failover is slower because of we're depending on the route convergence. How fast can the route conversion, can the redundant path be chosen by the routing protocol? The LACP is using the layer 2 bonding protocol, so the failover is extremely fast. However, it's point-to-point tunnel, so that means the two tunnel have to terminate on the same CMG. And also, if you're going to have multiple HSA for the remote side, we're going to have to, on the CMG side, we must configure multiple VPN instance. That means each instance is only used by one tunnel for one HSA. So for example, we have one HSA with 2 tunnels, we're going to have 2 instances of VPN on the CMG and 2 instances of HSA, VPN on the HSA. If we're going to have another HSA, we have to create another 2 VPN instance dedicated for the other HSA because it's point to point. So now with the fundamentals been explained, you can always refer to our documentations. There's another link talking about LACP. So just go straight to do the demo. And I have on the right side, I have the console to HSA. And because I have some previous configurations, so what I would do is I would do a write erase to start from scratch so we can do this together. Here, I'll just reboot it. After write erase, just do a reboot. You get a fresh default config. So on the CMG side, I'm going to remote into my CMG. For the configuration, we have explained many times on the how to configure VPN instances on the server side. So again, the principles are similar. We're going to have, because it's a layer 2 tunnel, we have to be in tab mode. So the key configuration is we're going to have configured bounding interface on both sides. And bounding can be different modes, but the most recommended mode is the LACP, which is L2.380 standard protocol. Then the bounding group config has to be under the VPN server. So once the VPN server instance is started, you will automatically enable the tab interface and assign the tab interface to the respective bounding group. And similarly, we're going to have, because we're going to have 2 instance, 2 VPN tunnel under the same bounding group. So we configure the other VPN instance. And because I have only 1 IP address on the server side, so I just have to use different port number to specify different instances. If you have multiple IP address for the same CMG, it's recommended to have different IP address for different instances. But in this case, I'm just going to have 1 IP with different port number to activate different VPN instance. So just going to copy this config on the server side. So once the VPN is started, it automatically creates this, adds this command. Once the tab interface is up, you add this command. And if you show interface brief, so we can see the tab interface is up because we are not assigning any IP address to the tab interface, or rather to the tunnel pool. So the tab has no IP address, and the bounding has IP address. And if you're going to show bounding group 0, so you can actually see the 2 tab interface are automatically assigned to the bounding group 0, and it's using IEEE protocol. So again, these commands are automatically added to the tab 1 bounding group 1. So if we stop, for example, stop this instance, if you look at it, you stop this interface, the tab 1 command automatically disappear. It was there just now, and the tab is gone as well. The tab interface is gone. We can just show interface. So the tab interface is gone. There's only tab 1 there, and you can also show interface bound 0, and I can only see tab 2. So again, I'm going to start again. So just to start the tunnel, and you can show run again. You can see tab 1 config is back, and show interface bound group 0, and tab 1 is automatically assigned to bounding group 1 as well. So that's all we need to do on the server side. So I've got the fresh config already boot up on the HSA. So there's nothing, and just to get the default IP address is 1.1. So make sure, okay, I have a connection to that one of the LAN port. So I just switch my LAN connection to 192.1.1. And I'm just going to connect to that IP so that we can manage the interface from here. And I've already slotted in the SIM card, so the two LTE interface are already up and running. So I'm just going to make sure I have assigned to the right APN. Depends on which provider you use. Change for the other APN as well. And in this lab, we're going to have two tab interface, or rather two tunnel, and they are sharing the same IP address on the gateway and just share using different port number. So how can we make sure, for example, the tunnels are mapped to the respective LTE connection? Because if you have both LTE connected to the internet, and the connection is very much depends on the routing table. So how can we map, for example, this tunnel to use LTE and the other tunnel to use LTE2? So we're going to make use of our multi-WAN connection to do the mapping. So essentially, we're going to configure policy-based routing. That means for tunnel 1, we're going to use LTE1, or rather LTE0. And for tunnel 2, we're going to use the other LTE. And we're going to still do failover between this LTE connection. That means if this LTE goes down, this tunnel, we can either tear down the tunnel, or we can make this tunnel failover to use the other LTE connection, so the bonding doesn't break. So we're going to configure the policy-based routing to make it a little bit more complex or interesting for today's demo. So I will configure policy-based routing to map the LTE connection to the respective tunnel, or rather to force the respective tunnel to use the respective LTE connection while still enjoy failover between the LTE. So what happens is now we're going to configure LTE0 and LTE1 to the load balancing group. And before we can do that, we have to configure the gateway matrix, just assign anything that is unique for each interface. T0, just anything. So just add the LTE interface to the load balancing group. We have always been talking about using load balancing to do the failover and also bonding or bandwidth aggregation. Today, we're going to showcase how to use the M1 or other load balancing feature to do the policy-based routing. So just add the LTE interface to the M1 group first. So what we would do now is to have multiple M1 group, or rather balancing group, and with each one focusing on its own VPN tunnel. So I will explain that in a little bit more details as we go along. So the first thing is we're going to configure one member. That means use this one. I will assign metric 1, 1. And the same LTE interface, but I will assign metric 2, and the weight doesn't matter. So LTE1, the other mobile connection, metric 1, 1. And sorry, back to, okay, so metric 1, 2, this one assigned to 2. So what I'm trying to do now is, that means for tunnel 1, I'm going to use LT0 interface with gateway matrix 1, which means it's going to be the active one, and use LT1 as the backup. So that means because it has higher metric, so it becomes backup. So tab 1 or the tunnel 1. So I will use LT1 and LT0 with metric 1. That means it's the active one, and LT1 with metric 2. That means it's the standby for tunnel 1. Okay, so that's how it. Then we're going to map to the port number later. So tab 2, we can do the two similar, but this time we're going to use LT1 with metric 1 as the active one, and LT0 with metric 2, so it becomes backup. So this just defines the policy. So the next thing is to map the policy to the traffic. So again, just review. Policy tab 1, that means tunnel 1. We're going to have LT0 with gateway metric 1, so that means it's the active, and this is the backup. And for tunnel 2, LT1 is active, and this is the backup. So I'm just going to define the traffic. LT1, tunnel 1. So because we're going to have the port number 1443 and protocol TCP, that's it. So we're going to map to the policy tab 1. So there's a lot of interesting combination you can use to do policy-based routing. So we just simply map into the by port number TCP 1443, which is tunnel 1 on the gateway. So if you show interface, if you show the configuration that we have done just now, we're going to use 1443 for tunnel 1 and 2443 for tunnel 2. And if you show TCP, and these two are listening, so it's configured on the gateway, and we have also configured the firewall to allow the TCP 1443 and 2443 to come in. So the gateway now is ready to accept connections. I'm going to configure for tunnel 2 policy, TCP tab 2. So this will basically force the traffic for tunnel 1 to go through LT0 as the primary and LT1 as the backup. Likewise for tunnel 2, and this is the primary and this is backup. So if you go to the M1 overall status, you actually say tab 1 using LT 100% because that's the primary, and tab 2 use LT1 100%. So this is the other tunnel using the other LT interface as the primary, and they will back up to each other because we have already made this policy. That means tab 1 have this as backup, tab 2 have this as backup. So again, if you have assigned the interface with higher metric, it becomes the backup to the one that has lower metric. So we have configured load balancing to be ready to accept to build the tunnel. So we're going to configure the logical interface here so that they can map to the respective firewall zone. Just configure tab 1, unmanaged. Assign this to LAN so that we don't have to worry about firewall forwarding between zones. Everybody's on the same secure zone for all the tunnels. Just configure the other tunnel, tab 2. Same firewall zone. And now, because we're going to have boundary interface, that's another logical interface, and it's actually the IP address are assigned on the boundary interface, not on the tab interface. So we have to create another separate logical interface to map to bound 0. So just configure a bound 0 interface, and there's already a built-in boundary interface. The kernel already starts with a bound 0. So we're going to assign an IP address of this one because on the gateway side we have already assigned a bound 0 IP address of this one. So we're going to assign 2. You can have whether it's 224 or /30. it doesn't matter, and assign to the same secure zone so that we don't have to worry about firewalling. Okay, so we have configured the tab interface, which is to map to the respective tunnel, and we have also configured the bonding interface, which is supposed to bond these two VPN tunnel into one logical link. And there's no traffic yet because the bonding is not up, the tab is not up. So we have also configured the two LTE interface to auto balancing or the M1 group so that they can provide failover to, and also primarily it provides mapping to the VPN tunnel, so we can force the tunnel to go through the respective LTE connection as primary and use the other one as backup. So there's redundancy, and we have already configured that just to make sure, because we configured that interface just now, so I just do a restart. So the typical flow is we'll probably configure the interface first before we configure the M1. Okay, so it is running now. So I'm going to configure the import the VPN profile on the HSA. Profile 1. Paste. We're going to use similar syntax. Okay, assign this to bound 0 and start it. So while we're waiting for the interface to come up, I'm just going to export out the other profile. So as you can see, this actually automatically, once the tab interface is up, it assigns that tab into the bonding group. So I'm just going to copy and paste the profile to paste tab on group 0 start. Okay, once the tab 2 is up, you can see the message that it's been assigned to bound 0. So if you show interface bound 0, it gets very similar output, similar to the gateway side. So they're all using the same protocol, and tab 1 is assigned to bound 0, tab 2 is assigned to bound 0. So as you can see, the configuration is really simple. And now the interface bound 0 is also up. It gets, we configured the IP address just now. So just try to do a pin across the bonding interface. So it's up and running. So if you do a TCP dump on the gateway side, so the traffic is definitely going through the bonding interface. So because we're having tab interface in randomly, so the traffic will literally round robin across to tunnel. So if I do dump on the other interface, you can see the traffic is going through both tunnel. Then logically on the bonding interface is a complete request and reply. So the bonding basically is up and running very well. So just do a VPN failover just to show how fast the bonding can do during failover. So what I will do is I will shut down tunnel 1. So we have seen traffic on tunnel 1 just now. You can see it randomly. And just going to stop this right now. So please pay attention to on the right side. So I'm just going to stop now, so whether the pin stops or not. Okay, so it's just a slight pause, maximum 1 packet drop, it continues. So now if you show the traffic, everything goes to the other tunnel. Okay? So on the bonding interface side, is still everything logically on the bonding interface. You don't see any failure. Okay, So now I'm going to bring up tab 1, and I'm going to shut on the tab 2, or rather the other tunnel, just to see the failover still works. Okay, and just the pin finish. So there was one packet loss just now during the failover. So I'm going to stop the other tunnel to make sure the pin still continues. Okay, so the pin again had a slight pause, then straight away fails over. So the failover, as you can see, is extremely fast compared with Ospf, which is very much depends on the Ospf hello timer, which defines how fast the Ospf routes can be converged. But of course, they're really used for different scenario. Again, Ospf is more for large deployments. One hub site, you can support many remote HSA. That means one tunnel, one tab interface here can have many peers of HSA, but for bonding is point to point. So in terms of scalability or ease of configuration, you really have to understand what you are trying to achieve. So in using bonding, you get really fast failover and aggregated bandwidth. Using Ospf is very scalable and very easy to deploy. So I'm going to start bonding 0 again. Okay, just now I forgot to show the, so let's say we're going to have, just to make sure the bonding was really working, I stop. And just going to show the interface 0 so that everything is going to the tab, just to make sure the tab still works. Okay, there was a little bit slight delay and for this failover. Sometimes one very important point to take note is if you want to do bonding, you really have to make sure the two connections that you have similar performance, because if one of the connection is bad, it drags down the overall tunnel performance. Okay. So now I'm just on tab 2 only. So I'm going, let's say if I bring back tab 1, the pin still continues, and we're having both tabs in the same bonding interface. So you can keep on playing with this in your lab, and we highly encourage you to do very thorough testing before you deploy to the real environment. Again, make sure the performance of the two links are similar if you want to have a aggregated throughput and getting the fastest failover. Okay, that's all for today. Thank you very much for watching. I will see you again in our next session.